Hello, welcome to implementing passwordless logins with WebAuthn protocol. My name is Adib Saikali. I've been a software developer since 1995, and I like to joke I've been a code janitor since 2014. I'm currently a global field principal at VMware Tanzu, focused on Kubernetes, Cloud Foundry, and Spring. I spend a lot of my time working with customers on cloud-native application architectures, both modular monoliths and microservices. I spent a lot of time also on application modernization and refactoring patterns. And for the last little while, I've been doing a lot of stuff around application security. I'm also currently authoring a book called Securing Cloud Applications for Manning Publications. You're going to learn everything that I'm covering today and much more in the book. So I want to start off with a thought experiment that I want you to think about. So imagine that you've built an application which is following all the secure application coding practices. You've even hired a security consulting firm to audit your code and check that you're not making any kind of the typical mistakes. You've trained your users to use all of the strong password best practices and management practices for passwords. And your application actually has two-factor authentication. So when users log in, they have to give a password and they have to give a second factor, like a one-time token from one of the authenticator apps. The question is, how do you break into this application, this super secure application? And the answer is, if the application is very secure, what you attack is the human that's using the application. And so the way we do that is typically it's called phishing. So the hackers are going to build a website with a login screen that looks just like the real site that the user wants to log into. Then they trick that person into going to that fake website where the person enters in the actual username, password, and the one-time token credential. And then once the hacker website has it, they use those credentials to access the real site and steal money or do unauthorized things or steal the user's data. So the key thing, doesn't matter how strong the technology is, humans can be phished. Humans can be socially engineered into doing something they're not supposed to do. We've all seen these like action movies, heist movies, where there's some really sophisticated security system with guards and all this type of stuff. And part of how they break in and pull off the heist in the movies is they pretend to be someone they're not. They socially engineer the front gate, the security guard, or something like that. Humans, that can happen. So what we need is a phishing-resistant authenticator that can validate that the user is accessing the real website and not ever complete an authentication against the phishing site. Luckily, this is a fairly well-developed technology. It's been around for a while. So there are lots of choices on how to do it. That's the kind of authenticators that are phishing resistant. You can see on the left-hand side my personal collection of authentication keys from three YubiKeys, the blue one and the two black ones, and the right one is the Google Titan key. Now, all of these keys are work, and you can program them and add them into your application using a fairly standard protocol that we're talking about today called the Web Authentication API. It's not really a protocol, it's an API. And the other group of authenticators are called platform authenticators. These are practically built into all the user's devices. They are here for free. The user doesn't have to go out and purchase a physical device. So for example, your iPhone's FaceId, the thumbprint scanner in your laptop, all operating systems pretty much support them. Mac OS does, iOS does, Android does, and Windows, like Windows Hello, supports this stuff. So the point here that I'm trying to get at is this is widely available. You can start using it. So I'm going to start with a demo of what does the web authentication protocol experience look like from the point of view of a user. Then I'm going to go into explaining how that demo works, like underneath the hood, like what's happening. Then we're going to dive into a demo application that's designed to teach you how all this stuff works, and we're going to look at what's happening in the code of that application. So I'm going to head over to this website here. Let me just click on the link, WebAuthn.io. Oh, here I am. And what I'm going to do is I'm going to use this website twice. First, I'm going to use it for my laptop, and I also have my iPhone here. So I'm going to go here and let's pull up my iPhone. Okay, here we go. So we're going to have two browsers. The one on the left is on my Mac, and the one on the right is on my iPhone. So we'll start off here, and let's pick a name. I'm going to call this one Adib2 is the username. And first I have to register. So when I click on register, that's when my browser pops up this nice dialog box, and it says, oh, I see you would like to associate a hardware or some sort of authenticator with this website that you're trying to visit. Here are your choices. Would you like to use a USB security key, or would you like to use this particular laptop? So I'm going to use this case a USB security key. Now you can't see it on the camera, but there's that blue YubiKey that you saw in the photo earlier. It's plugged into my laptop. It's flashing. I got to go and press the button, and success. It says now I can log in. All right, well, let's actually see what happens if I do that. So if I click on login, I get this dialog box again. And this time it's basically saying verify your identity to WebAuthn.io. Okay, well, how would you like to do that? I'm going to use a security key. So it's flashing again. I'm going to go and press that. Presto, I'm in. And what you can see that the backend application, what it knows about me, it knows the public key. So what's happened is that there's a public-private key pair that was generated inside of the authenticator, and it knows the public portion of that. We'll talk a little bit more about that later. Let's actually continue on, and this time here, let's actually create the same user. Oops, I got to do that. I can't type that. I have to use my phone. So I'm going to go here and I'm going to type Adib2, and I'm going to click on register. And you'll notice that my phone is giving me a choice. It's giving me a choice to use the FaceId, which is built into the iPhone, or use my security USB key. So I'm going to opt into using FaceId. And as you can see, that kind of worked. Perfect. And let's try logging in now. Oh, I gotta click on my phone. So again, when I tap my phone for login, I'm asked I want to use a security key or FaceId. I'm going to go for FaceId because that's what I used. Ta-da, I'm in. Now this time, if we scroll down here, what we're going to see is now there are two keys that are registered with the Adib2 user ID. One that I did earlier, which is the YubiKey, and the other one that I just did on my iPhone, which is related to FaceId. So if I refresh this page, now I've got the two public keys that it knows about me. Let's actually go and try this again. So we're going to now do Adib2. Let's try register. It pops up. This time I'm going to register the actual laptop. And you can see it popped up the standard macOS. Please scan your thumb. Okay, now I can do a login. And because I have that, my thumbprint, now it's asking me for that. And if I log in, I should see now there are three public keys that are known about me. There's the public key that's associated with the YubiKey that I did first. There's a public key that's associated with the iPhone, with the FaceId on the iPhone. And there's a public key that's associated with the actual macOS thumb scanner. So that's kind of a pretty neat trick here, because I was never asked for a password, right? And we're using public key cryptography, which is well known and quite secure for doing these kinds of operations. So let's go back to the slides for a little bit and just look at what we actually did and what happened. So the way that these phishing authenticators work is the authenticator is going to generate a unique public-private key pair to identify a user on a specific website. The private key is never going to leave the authenticator. It's going to be stored in its secure storage facilities. The public key is what you share with the website that you're logging into. So when you come back to the website, you want to log in without a password, or you want to log in using the key as a second factor, the authenticator is going to be asked to complete the authentication process, to log in, to complete the login process. And what the authenticator is going to be given by the web browser is going to tell it, this is the actual URL, domain name, host, port number that this user is on right now. And I want you to try to log into this URL with this particular user ID, with this set of matching public keys. And the authenticator is going to search through its internal database. And if you are on a fake website, it's not going to find anything. It's going to come back and say, I don't know how to log into this because I have no public-private key pair that matches the fake website. But if you are on the real site, it'll say, aha, I know exactly how to solve this, how to complete the login and solve this cryptographic challenge. So the bottom line is you can fool the human into thinking they're on the real website, but you can't fool the actual web browser because the web browser knows where you are. It knows the URL. And the authenticator is checking with the web browser. It's not checking with the human to validate where you're at. So underneath all of this are really two things. One is two standards. One is the CTAP2, which is the Client to Authenticator Protocol. This is an actual protocol that defines how these hardware keys are going to interact with an actual device, with a phone or with a laptop or a desktop. And the specification is fairly low level. It's defined by an industry consortium called FIDO Alliance. And it's what allows me to use the Google Titan key, the YubiKey, or any other manufacturer of these keys. They're all interoperable because they all in the hardware implement this CTAP2 protocol. Now, you don't write your application code against CTAP2. What you do is you write your application code against the Web Authentication protocol. Now, the Web Authentication protocol is a browser-based JavaScript API. And luckily for us, as of today, 90.4% of browsers support the Web Authentication protocol. So your code calls the JavaScript API. The JavaScript API in turn turns around through the browser and calls the underlying authenticator via the CTAP2 protocol and the OS libraries. So here's kind of more of an architecture diagram that shows how this works. So we're going to have the on the client side, you're going to have the web browser. It's going to download some JavaScript from the server-side application known as the relying party in the terminology of the protocol. And what will happen is that you're going to do two things. One is you're going to first register the authenticator, which is what I did, just one flow. The other one is authenticating. And so you'll see here the Web Authentication API in browser is going to, when your application calls it, it's going to call the platform authentication API, like your Mac OS, your Windows, hello, whatever it is. And that is then in turn going to talk to any one of these external hardware authenticators, the cross-platform ones, using this CTAP protocol. So main message here is this is widely available. This is widely deployed. Your users already own phones and devices that are capable of doing this. All you got to do is add web authentication to your web apps, right? Some famous ones that currently support it, for example, GitHub, you can actually register these keys and use it. Facebook, you can use this with it. Gmail, you can use it with it. Of course, with all your cloud consoles, you know, your AWS, your GCP, or your Azure, you can do the same thing. So what I want to show you now is get a little bit deeper on this and go into the code. So I've written a sample educational application using Spring for the backend and the Yubico Java library. And on the front end, what I'm doing is I'm using plain old jQuery with raw JavaScript. So you can kind of wrap your head around how this protocol works so you can actually add it to your own application. For the backend, if you're a Java developer, the Yubico library is wonderful. On the front end, there are some really good, GitHub publishes a really good JavaScript client library, but I didn't want to use it in the sample app because I did not, I wanted it to be very educational, and it was easier to be educational by just using jQuery. If you go through to the Git repo, you'll see that it's going to tell you how to run the application, and it also will point you to certain pieces of code and say, hey, go check out how this code works, go check out how that code works, so you can try and wrap your head around it. So let's actually see what this sample application does and talk a little bit about, see this protocol in action. So let me switch here to my IDE. And so what's happening here is the following. We have, I have the application running. Like I said, it's just a simple Spring Boot application. And I can go to localhost 8083 to access it. So let's go here. Let's refresh this page. And the thing you'll notice here is it's using HTTPS, even though it's running on localhost. The reason why is that these web authenticators, the protocol requires it, the WebAuthn requires it. If you are on an HTTP address and you try to interact with things, it's going to say, that's insecure. I'm not going to do any pub registration or logins with that. Please use HTTPS. So the first thing we have to do is to create an account. And what I'm doing here is I'm going to, I have on the right-hand side breakpoints in the JavaScript so you can see what's going on. So let's pick this. And we're just going to do like, I don't know, at example.com. All right, so we'll register with that. So let's do submit. And what's happening here is the following. So I have a jQuery listener, which is when you hit the submit button, it intercepts the request. It pulls out what was typed into the form, and it's going to make an HTTP post to the server. So the way that this app works is that in order to be educational, it prints out to the screen the JSON that it is sending to the server and the JSON that the server, the Spring Boot application, is sending back to it. So what's happening here now is we're going to say $Ajax. We're going to do an HTTP post to this particular URL, which is just a Spring MVC controller that I wrote on the backend. The Spring MVC controller, in turn, is going to call the Ubico libraries for web authentication to kind of make this work. So I don't have to implement the tricky logic for doing what the backend is supposed to do. There's a nice library that you can use, and what I like about the Ubico library, it has a lot of safeguards to try and force you to use it the right way. So what we're going to do is we're gonna send this to the server. So let's see what the server sends back. Great, we sent this to the server. Server got back a response. Let's see what that response is. You can see it right here. So there's two elements to this response. One part here, this flow ID, this is just a correlation ID that I'm creating to track requests and responses, record them in a database so I can debug it and you can learn how it works. This second part here, the credential creation options, is pretty interesting. This object was, this JSON object was generated by the Ubico libraries on the backend. And what it's designed to do is to tell the JavaScript in the front end how it should call the Web Authentication API, what options it should pass to the Web Authentication API. So we're telling it that it should identify the backend application as the example application, that the application is on localhost. It should specify the user. So this is the name of the user that's registering. This is the display name. This is the ID on the server of the user. There's a cryptographic challenge that is supposed to be solved with this request response flow. And these public key cred parameters are identifying the types of public key algorithms that the server supports. So for example, RSA or elliptic curve. And there's a bunch of other options that unfortunately we don't have time to get into today. So that's the create credentials options. What's going to happen here next is, let me just skip over this guy here. And we're going to go to the section that says public key. On the public key here, when we get into the create credential option, we need to call the API, but the API for web authentication expects certain things to be JavaScript byte arrays, whereas the server gives us URL encoded base64. So we need to do some data conversion. And that's what I'm doing on line 88 through line 101. So let's just skip over that and continue on. And at this point here, we're going to get to navigator.credentials.create. This is actually where we're going to call the Web Authentication API. And let's see what happens when we do that. Oh, look, we got a dialog box. And what our dialog box is telling us to say, hey, how would you like to identify yourself to this app? So I'm going to click on the USB security key, and my YubiKey is flashing. I'm going to go and press that. And when I press that, you can see here that I'm in the success handler for this. And what that means is that a public-private key pair has been generated. Now we need to communicate the public key to the Spring Boot application so it can register it in the database. and associated with the user. So what I'm going to do now is I'm going to just hit continue, and I'm going to end up in the finish registration step. And what we're doing in the finish registration step is we're doing two things. One is we've got this, we're creating a JavaScript object to send to the server. Let's actually see what that JavaScript object looks like. This is the JavaScript we're going to send back. You can see here the credential, the ID, this raw ID. This is information that came back from Web Authentication API. We're packaging it up in this credential object because that's what the Ubico library wants the JSON to look like, and it's easier to deserialize it. So I'm going to then skip over, continue this. And now that it sent it to the server is going to come back and say, yeah, everything is good. Now there should be a user that can log in. So if I go here to the login screen, and I can type adib@example.com, click on login, what's going to happen is it's going to say, all right, same thing that I did before. jQuery is going to intercept the call, and we're going to start the login process. So you can see here, what I'm going to do is I'm going to do an HTTP post to this URL, which is a standard Spring MVC controller, is going to kick off the, hey, I want to log in. So we're telling the website that we want to log in, and the website is going to come back and say, okay, if you want to log in, what I want you to do is I want you to use the authenticator, and specifically, this is a cryptographic challenge I want you to solve. This is the ID of the site, and I would like to use, this is the public key that I have about this user. Hey, authenticator, can you go into your database as the authenticator, find the private key that belongs to this public key, solve the cryptographic challenge, and give me back the response. And if you succeed in solving the cryptographic challenge, then I know that this is the user, and therefore I will let them in. So let's actually see what happens when create credential is called. So this is the create credential function. What we're going to do is we're going to need to generate a very specific object to give to it. We need to do some data munging. So we're just going to skip over the data munging piece here. And we're going to get to the part where we're going to say navigator.credentials.get. We're not calling .create, we're calling .get. So what we're saying here is, hey, can you please take this public key, this information about the public key, and create an assertion out of it. So let's watch that happen. Now we get the little pop-up. We're going to use the USB security key. I'm going to go and press the UB key. And now we're in success. Yes, we've been able to successfully log in, or the authenticator has been able to successfully solve the cryptographic challenge. So now what we're going to do is we're going to say we need to report to the server the result of interacting with the user on the authenticator. So I'm just creating the JavaScript object to send to the user here. And that's what the login finish request is all about. It's like, hey, I'm done with the login. I'm going to post this now to the Spring Security login endpoint. You can see down here. Here's the username. Here's the finish. Spring Security is going to intercept that. I had to add a custom filter that handles this. You can see it in the backend Java code. And so if this works, it's going to say, yeah, everything is, you're logged in now. We know who you are, right? So what that allows me to do is to go here, and I can go to this page, and I can actually see the page, and I can see what my application is doing. So to kind of recap what we did is we had to write a bunch of JavaScript to interact with the Web Authentication protocol in order to register a hardware authenticator key, in this case a UB key, with the Spring Boot backend. And then when we came back to log in, we used it as part of the login process. We were not asked for a password because I didn't configure this thing to use passwords. You can use these Web Authentication to do passwordless login or to do as a second factor. Realistically speaking, if you lose the key, well, too bad, you lose access to the site. So you probably want to use it typically as a second factor. rather than completely passwordless registration and passwordless login. Depends on your application, what you're doing. Fortunately, don't have time to get into all the how do you decide which way to go in the short session that we have together today. On the back end, it is a Java application, like I said, pretty standard vanilla Spring Security and Spring Boot. Unfortunately, due to time constraint, I don't have time to get into the backend code, but I hope you actually learned a lot so far from this introduction to the web authentication and protocol. So again, thanks so much for your time. I hope you check out my book. I'll take any questions you have.
Hi, Edith. Thanks for the great presentation. Very interesting topic. It's actually good that the talk was actually online and not live, because if you see my password spread everywhere, you probably wouldn't be too happy, but that's live. I have actually a couple of questions for you while I wait to see if there are some coming from the audience. The way you started talking about attack the human, that's something that remember me a bit when I was young, reading the Art of Deception and the entire concept of social engineering, coming from basically at the beginning, hack the phone, then hack the computer. Anyway, you try always to get on the weak link of the chain. So I was wondering, where is going to be with passwordless technology, the weak link? Is still the person with the YubiKey in his hand? I mean, is the goal then going to be to protect the YubiKey or your phone or whatever?
So the goal is to help the human not fall for the fake website, right? By having the YubiKey, the hardware authenticator, like check that this is in fact the correct website that the user intended to be on. Because usually, like you're being attacked during login, not during registration, more often than not. So if you get sent to a fake website and you register there, that's a different type of attack that this thing won't help you with. But if you already have an account and you just went to the fake looking site and you provided your credentials, that's what this is stopping you from doing. And the way that it stops you from doing it is that when you get asked to log in, you press the key. So like GitHub does this really well, because what happens with the GitHub scenario, with the GitHub app, is you still have a password with GitHub. But it's like when you go back and you're like, I need to create a developer key, I need to do something sensitive, it will, my expectation now is I don't have to type in my password, because it's going to ask me to just touch the key, which makes my life easier, because I don't have to fumble with my password manager to go copy and paste it in. So that's pretty neat.
So it's still a sort of a second layer in that scenario of GitHub.
Yeah.
So it's not the first and single layer. So you are in the scenario you describe as when you still use two different parts.
Yeah, you still use it like a secondary with a password. Now, let's think of say you're building an application that's aimed at human users, like B2C, and how many people are just abandoned, including myself. Think of when you just abandoned a website because they want you to create an account. And you're like, oh, crap, I have to think of a password, all this type of stuff. In that scenario, you're more like kind of evaluating whether you even want to use the product or not. I think it's pretty handy in that case, because what you can do is you can kind of type in your email address or your user ID, use your phone or whatever device you're using to kind of finish creating the access to the account. Start using the application. And if you like it, the application, when you come back, can insist you set up a password, and then it becomes a second factor with the web authentication. Does that make sense?
That makes a lot of sense, and actually address what would have been my next question, because of course, usually you have that kind of feeling of, with any two-factor authentication, any hardware device, you have that feeling of, oh, it's going to make the usability worse. It's going to be good for my sysadmin because, well, it's okay, a higher level of security needs to do it. But for the general user, it's going to be harder. But at the same time, you're right. I mean, there's one side of the world that is, I don't need to generate password, and the sign up can be much smoother, as you did in your example. So that's actually
and this is really it actually is making the user experience much better. So what I find it's interesting about it is because it works on the phone and it works on like the Mac T2 chip and the Windows Hello, all of these sites always like GitHub, like they allow you to register multiple keys.
Yes.
So if you happen to be, say, getting into GitHub from your phone and you use Face ID, it'll just ask for that. If you happen to be in um, in like something else, then it will ask for it. Because what's happening is that the backend application will know which public keys identify the user, and then the authenticator can select the right matching private key. And this also allows you to have multiple private keys, multiple physical keys in case you lose one.
Okay, that actually addressed part of the problem I had with a single key, and actually raised one of them, a very interesting question from the audience, that is, how do you deal when you have multiple devices? The common scenario is, and you were part of this, and that is, if I have no one has anymore, just either only the phone or only the laptop. So whatever you have multiple devices is quite a common scenario. So I want to, yes, it's cool to have the YubiKey in my laptop, but I want to be able to access the device, apart from GitHub, that maybe is still a developer tool, but I might want to access the website from multiple devices. So how do you handle that?
Well, you have to register multiple authenticators because you have a private public key pair that identifies you, and the private key is always going to be in the authenticator. It never leaves the authenticator. So currently, there isn't, unfortunately, a way for you to synchronize all of your keys. But the FIDO Alliance just put out a white paper in March talking about an approach that they're proposing to allow for the like kind of replication of your private keys from these things. So they could, for example, you can imagine something like Apple already lets me cut and paste between my iOS device and my Mac. Why can't they replicate the key? So it's available in some secure way that only they can do for their technology. So I can imagine that those will come as this becomes more popular. You know, my goal with the talk was to really just raise awareness that, hey, this thing is available. 90% browsers support it. Like, what are you waiting for? You could add this to your application today, right? And they'll improve the usability of the app and security.
That's very cool. So what you say basically is, in the example you made of using the iPhone with face recognition, made, for example, and a YubiKey on my laptop, technically there are two private keys, each one independent, and each one sitting in the device and never leaving the device. Correct?
Correct. Yeah, which is pretty neat, because it also means you can invalidate this. There's a lot more about this I didn't show. Like, for example, corporations, they might basically say, we'd like you to use this as a second factor, but there's a very specific brand of device we want you to use. We don't want you to just bring some random no-name knockoff authenticator that might be not secure, right? So there's actually a capability for the backend application to insist on, I'm looking for this particular model of authenticator.
So, otherwise, for example, it has to be a physical hardware authenticator and not, for example, a phone or those kind of requirements.
Yeah, because your company may have given it to you. The other thing that I didn't talk about is there's an option to basically request that the authenticator identify the user. So there's, like, for example, if I used Face ID, it's only going to work on my face, in theory, right? Or if I use the thumbprint scanner, it's only going to work with my finger unless somebody cut off my finger. I don't know. And so you could, if the authenticator has like a biometrics on it, then you can ask for, hey, can you ask the user, can you identify and prove that it's that user? If you have like a regular YubiKey that doesn't have a thumbprint scanner in it, and you require that, it'll actually prompt you to set a PIN on the authenticator itself. So in order to acknowledge and press the button to say please log in, you'd have to first know the PIN. So this stops from random person finding it on the street to actually using it to log you in.
Okay, so and that addresses the problem of the lost key or whatever is.
Yeah. Okay. It's like, think about it a little bit like you have a physical house key, and then
I was thinking that
somebody finds it and they can get into your house if they know where you live from this key, right?
That's really pretty neat. I have one more question about when you mentioned that it's widely available. You mentioned that, for example, it was 90.4% of the browser already supported. Is that, and as well in terms of devices, you made the example with the iPhone and face recognition. I was wondering, do you need any specific device? I mean, is supported on Android, any recent version?
It's supported on Android. It's like a couple of weeks ago, I did a webinar with a customer, and we had 235 people show up for it. And then I asked people to try out using their devices, and pretty much 87% of those people were successful from a group of 200 something. It's just the user interface is slightly different on Android, and I would actually encourage everyone. I'll throw that in the message. If you go to WebAuthn.io, just go with your various devices that you have, your Android, your old iPhone,
and try.
And I'm really fascinated by how these things react, because it's just a piece of JavaScript that calls the browser, and then something happens, but it's always platform specific, like the shape of the dialog box you get. So if you try this with Safari, it works. If you try it with Firefox, it works. But Firefox is got like the worst UI for this, and it doesn't work with. It only works with cross-platform authenticators. It doesn't seem to work with the chip, like on the Mac. So there's some limitations. It's definitely worth time for developers to start learning this.
Absolutely. No, I was more wondering if it was widely available, but basically mainly to the US and European market, or if we can consider widely available everywhere, basically.
It's widely available everywhere because the API.
Yeah, I was thinking mainly about mobile devices because, of course, a YubiKey, you can buy it everywhere, but the cost of YubiKey might as well be significant for not for an administrator, but for a user that maybe just wanted to register to a simple website.
Right.
Maybe it's not the main device you want to have. So I was mainly thinking about mobile technology.
Yeah, I mean, like a true story, like the electrician that renovated my house, he logged into a Windows machine at a job site, and he was using Chrome and Gmail to manage his passwords. Within 2 hours, like people were buying laptops. Something was buying laptops all over the world with his information. People were draining his bank account. He was able to put a stop to it, right? And only lost a few $1,000s. And at the end, Google basically came back to him and said, A, never log into an untrusted computer, but B, here's, you should buy a Titan key to stop that. Because if you had a Titan key, you wouldn't have been able to, you wouldn't have been able to authenticate into it. So
that's pretty neat, actually. This example. I have a very last question for you because unfortunately we're running out of time. I'm really fascinated with this technology. I really would love to see them and have them. I was thinking, if I had to start now a project from scratch, I have no problem in thinking about that. I was thinking how I can sell and how you migrate to that from it. I mean, I have a project, I have something live. Management usually doesn't care too much about the authentication. You gave a good point about selling the concept that there's a new usability that maybe helps. But I was wondering if there's anything else and how you migrate to that, support both, how you're
going. So what I would say is that you want to be leveraging some sort of single sign-on server of some kind, right?
Okay.
It's the single sign-on server, which is the right place to put it. So if you have an application that today has, like a custom username and password flow that you've written your own thing, I would migrate that away to something like Okta or Auth0 or Spring Authorization Server or Keycloak or Ping Federate or any one of those.
As a first step, okay.
As a first step. So you're saying in my code, I just want to write a resource server using OpenID Connect. And then that resource, that login server that you create, that's where you do all this innovation with. I can let you log in with passwords. These are the one-time tokens. This is web authentication. So you can isolate it there. So in the same Git repo that somebody actually put it in.
Yeah, I saw that. I wanted to ask you, but I saw that it was already posted.
There's also a bunch of sample applications that show how to use the Spring Authorization Server, which allows you to build your own SSO service.
Okay. Thanks so much, Oliver, again, for this great presentation, this great introduction to passwordless technologies. And talk to you soon and see you that one in the next talk in a few minutes. Bye.